This video is going to discuss the basics of absolute value. There are a lot of different things you can do with absolute value, from just the basic evaluating all the way up to solving equations and inequalities. I want to stick with the basics here so that when you come into class tomorrow, you're ready to discuss everything there is to know about absolute value, and we can get to some of the harder stuff together. So my first question, what is absolute value? And I think a lot of times students immediately say, well, I know what the symbol looks like. I know it's two long bars. And I know if I take the absolute value of -8, I get 8. But the question is why? The definition of absolute value is actually a distance definition. When I'm finding the absolute value, it is the distance from that number to 0 on a number line. Now what we know about distance is it can't be negative, and that's why when I say what's the absolute value of -8, we don't say -8, it's 8. It's 8 spaces away from 0. You can pick a number line and you can visualize that. Just like the absolute value of 5 is still 5. The reason it didn't change is because that's a distance. I want to make sure you know where your calculator button is for absolute value in case you are working with something a little more complicated. Eventually we're going to look at graphs with absolute value, so this is going to come in handy. If you pull out your graphing calculator, you're going to go to the math button, and the math button is 3 down on the left side. It says math. And this screen should come up. We've been to the screen a little bit when it comes to simplifying fractions. We're going to actually go to the heading that says NUM. That stands for number. So you can use your right arrow. The very first one, ABS, looks like abs. That is actually what the calculator uses for absolute value. So if you hit enter on that, or you can hit number 1, you will get the bars show up. If you're working with an older calculator, it will just say ABS, but that lets you know that it is taking absolute value. So we can just check just to make sure we're on the right button. If I take the absolute value of -12, it should indeed tell me that it is 12. So just giving you some comfort level as far as your calculator and your basic definition. The first type of problem we're going to be looking at, though, is how do we solve equations with absolute value? So if you want to think, really the most basic equation would be something like this. The absolute value of x equals 3. So before we get into the ones that are on the screen, let's look at just something really basic. And we can think through it logically. What numbers could we put in that would make a true statement? Well, if x was 3, that would be an accurate statement, because 3 is 3 spaces away from 0. But it's also true if x was -3, because if -3 is 3 spaces away from 0 as well. And so what I'm really trying to illustrate is that you get two different answers. When it starts to become a more complicated equation, sometimes it's not easy to just look at it and say, oh, I know the answers are this and this. You have to do a little more of the legwork, and that's what I want to show you how to do this process. When you're doing these problems, I like to think of them as like you're setting up two branches of a tree. So if you look at this problem right here, the absolute value of 2x minus 5 equals 9. When I draw my tree branches, what it's saying is either 2x minus 5 does actually equal 9, so the absolute value bars didn't do anything, or 2x minus 5 was actually equal to -9, and the absolute value bars got rid of that negative. So you create two separate equations. They both solve the same way, but you'll get different results. So you're going to do the add 5 across the board. 2x equals 14 on this equation, 2x equals -4 on this equation. Notice you have different things resulting, even though the steps that you're taking are the same. So I'm going to divide by 2. So I get one answer of 7 and one answer of -2. Nice thing about any equation, if you want to see if you're right, you can take these numbers. You can take -7, or +7, you can take -2, and you can go back to your original equation, put it in for x, and see, does it make sense? If I put 7 in, do I get an answer of 9? If I put -2 in, do I get an answer of 9? Couple things with different varying levels of difficulty. The next one you'll notice is the same level of difficulty, and then the bottom two get a little more complicated. Some things that you want to keep in mind: you want to make sure that you isolate the absolute value bars. What I mean by that is this first one we just did and the one that we're getting ready to do here, the absolute value bars were alone on that side of the equal sign. That's still different than the third and fourth one, where we're going to have to do a little work before we're ready to do branches. The other thing is that it has to be equal to a positive number. Once you've isolated it, once you have the absolute value, for example, this one right here, if this would have said, what if it was equal to -15 instead of +15, then you would get no solution, because you'll never have an absolute value that creates a negative answer. So it's just some little things to think about when you're starting these problems. There will be some that you'll look and go, wait, that's not right. I can't be equal to a negative number, so my answer is no solution, and I'm moving on to the next one and not wasting any time doing math that's not necessary. This one is ready to go, perfectly fine. We've got the absolute value bar is isolated, so we're going to write our two statements. Either 6x minus 3 equals 15, or 6x minus 3 equals negative 15. We're going to add 3 to move that. So now I have that 6x equals 18, or 6x equals negative 12. Divide by 6, and depending on your comfort level, you can show a lot of steps, or you might be able to do this without showing as many steps. We get two answers again, 3 and negative 2. And if you want to check your work, take those numbers, plug it back into x in the original equation, and make sure that it makes a true statement. The next two, what makes them a little more difficult, is they're not ready as far as making branches. We need to isolate the absolute value. So if you look at this next problem, this 9 has got to go. So the way we move it to the other side is we do the opposite operation. We're going to add 9. And once you do that step, just one quick step, it is now an absolute value equation that's ready to solve. It's equal to a positive number, so we don't have to worry about not having any solutions. We're going to create two branches again. 4x plus 5 equals 23. 4x plus 5 equals negative 23. Subtract 5. So we have 4x equals 18. Subtract 5. 4x equals negative 28. We get two answers. I'm a little low on my screen here, so I'm just going to try to very small print put it in here. We have two answers again. 18 over 4 does not give you a whole number, but it does reduce. You get 9 over 2. If you want to write it as 3.5 instead of 9 over 2, or excuse me, 4.5 instead of 9 over 2, that's perfectly fine. The other one is an integer, though. You get negative 7. So we should be able to write that across the board as negative 7. There are my two answers. It was ready to go. The last problem, kind of the highest level of difficulty because it has so much going on around the absolute value bars. First thing I want to do is move the 4. So I have the 1/2, the absolute value of 3x minus 1 equals 5. Then I'm going to get rid of the half by multiplying by 2. Very important thing to point out, you cannot distribute that half. That is not a parentheses. Those are absolute value bars, and you can't try to put something into absolute value bars that wasn't there already. So we need to multiply by 2 instead to get the absolute value isolated. Now we're going to do our branches. So we have 3x minus 1 equals 10. 3x minus 1 equals negative 10. Again, kind of getting to the bottom of the page here, but we should be able to squeeze in our answers. Either 3x equals 11 or 3x equals negative 9. When we divide by 3, I'm just going to put my answer off to the side here. My answers are either 11/3, which does not reduce. You can write it as a decimal if you prefer, but 11/3 is great. Or negative 3. And again, like all of these that we did, you can take those answers, plug it back in to the original equation that was presented, and make sure it makes a true statement. You can even use your calculator in the absolute value button that I showed you. So that's an introduction as far as absolute value, what it means, both in words and visually, and then how to solve it. Tomorrow what we'll get into is how do we deal with absolute values when they're mixed with inequalities, which becomes a little more complicated.